All right, everyone. Sorry I was a minute or so late. I'm working with some new stuff this evening, some new streaming software. So hopefully this works out well for everyone. And hopefully it'll work out just great and everything will be great. If not, then we'll kind of try to figure it out as we go along here. So we'll be going through the review assignment. So if you've already checked it and you got everything right, this might not be the most helpful thing in the world for you. But we will. I can answer any additional questions you have too. Just type those into the chat, and I'll get to those as I see them. I might not get to them all right away, and there's usually a little bit of a delay with this kind of thing. So we'll do our best, and we'll just see how things go. If you're watching this later, then hey, how's it going? Hope this is helpful. So we're first going to go through these first two problems where I wanted you to sketch the graph by making a table of values. Now, what I will tell you is that I'm not necessarily expecting on your test that you make a table of values. I have a couple problems on there that I think the best option is making a table of values. But in reality, if you can find a way to make an accurate graph in some other way by converting to slope-intercept form or something like that, that's totally fine. Okay. But in this case, I'm going to try at least to make a table of values. And again, when you're making a table of values, that's why I wrote that equation with the blanks in there. That's basically what you're doing is you're playing a game of fill in the blanks. Fill in the blank for X, fill in the blank for Y. And as long as it makes the equation true, you are totally okay. So 0 after the 4 and a -1 in for the Y should totally work. Now, when you're trying to come up with points, it can sometimes be a little bit challenging there to really figure out points particularly easily. But I think one of the things that you could definitely do is, just you could do a little guess and check, and I'm going to show you a little trick right now, hopefully, after we get another point. So one of the points I'm thinking of here is -5 for Y, because that'll make that a 25, and then also a -5 for X, because that would make that, positive 25 and -20, which should make our 5 there. Now, one of the things you can do if you're a little bit struggling to come up with another point is you can go ahead and put both of those on your graph. Okay, and then what we can do is we can just look, well, what would our rise over run be in this particular situation? And it looks like we're going from this bottom point up here, that's up 5, and then over 4. So if we go up 5 again and over 4 again, we should come up with another point. Now, what we should do is we really should check that point, okay? So we should try 3 for X, and we should try 4 for Y and see if that works, okay? And what we find is 3 times 4 is 12. 5 times 4 is 20. So those don't work out. So that must have meant that if I go back and look, I must have done something wrong in here. And for the life of me, I can't exactly figure out what it is. So I'm going to look back, see what I did wrong here. Looks like 0 and -1 should work fine. And -5 for X and -5 for Y should totally work out fine. I think that's -20 and then positive 25. That should make positive 5. So all of those points look good. Oh, I see what I did. It's a mistake that I've seen in class a bunch of times, and now I just did it myself. Holy cow. I graphed 0, -1 wrong. That should be right here. Okay, so let's count our rise over run again. Good example of checking your errors. This is the kind of stuff that you only get with a live stream, everybody. So we're going up 4 and over 5. That seems to make a whole lot more sense. We're going to go up 4 over 5 again. Oops, that was only over 4. One more. And it looks like that third point is 5 for x and 3 for y, which gets you 20 minus 15, and that totally works out. Okay, so good example there, although to be honest, totally not on purpose, of why it's important to kind of check your work there and make sure your points work out. But what I did also demonstrate is it's a good way to figure out a third point too. See, I only figured out those two right off the bat, and then I figured out that third one by using the slope. But then what I did is I went back in and I made sure, do those actual values work in the equation? Okay. This second one should be a lot easier to come up with some points because plugging in 0 for both the variables and finding the intercepts works really well here. So 0, 3 works really well, and 2, 0 also works really well. Okay, so again, if you're still struggling to figure out that third one, you could continue to use, you could try to use slope here. I don't need to for this one. I think I can figure another one out. 3 times 4 is 12, and 2 times negative 3 is negative 6. So those should work too. Let's double check by plotting 4, negative 3. And it looks like those definitely make a straight line. So that's what your line should look like there. Again, on your test, I'm not necessarily going to tell you what method you need to use. So that's a little bit up to you. There are going to be two that are kind of designed for making a table, but if you can think of another way to do them, then totally go ahead. Okay. Next things. Both of these are slope-intercept form. This first one is a little bit tricky, but if we kind of think of that negative x as negative 1 over 1, now it looks a little bit more like slope-intercept form. We're still missing our plus b, but we could put a plus 0 at the end there too. The cool part about me not telling you, oh, and then we're going to do slope of negative 1 over 1, so we're going to go down 1 over 1, down 1 over 1. One of the things, though, that I think is pretty cool about me not telling you, like, hey, you've got to graph these using slope-intercept form. This is slope-intercept form, and that is kind of the best way I think that you should do it. But with that said, you could have done this one, number 3 here, by making a table, right? You could have gone x, y, and you could have just said, well, when x is 1, y is negative 1. When x is 2, y is negative 2. And you would add a whole set of points there really very quickly. Okay. Next things next. Let's check out this one. So this is slope-intercept form. Okay. Our y-intercept is negative 4, so we'll plot that. With negative slopes, so for a slope of negative 1/4, remember that means either the 1 is negative or the 4 is negative. It can't be both because those negatives would cancel each other out. So you can go down 1 and to the right 4 to get another point, or you can go up 1 and left 4 to get another point, and that'd be totally okay. All right, that's it for the graphing ones on the first page. Next page. Give me a second while I zoom in a little bit here. Now we're looking at point slope form. Again, I'm not going to force you to use point slope form, and I actually put 2 on here that you could probably transform into slope intercept form if you wanted, but I do want to caution you with doing that. Okay, as an example, if I simply change the slope in this problem to, instead of being -3, be like -3 over 7 or something ridiculous like that. Now this is a problem that you definitely want to do with point slope form. Otherwise, you're going to have a really hard time graphing things accurately. Okay, so make sure you know how to use point slope form, and that's what I'm going to use for these. So for using point slope form, what you really need to do is you need to find a starting point. Easiest way to find a starting point is to find the x and y value that make both sides 0. I would plug in -1 for x and 3 for y to make both sides 0. Keep in mind, x and y come in different orders in your ordered pair versus your equation. Make sure you get that order right. Let's plot that point first. There's -1, 3. And then I'm going to use my slope of -3. I'm going to make that over 1. So I go down 3 over 1. I can do that a few times, and I'm all set. Number 6, again, we've got a weird looking slope here, but we're going to assume that's a slope of -1. So it's really y minus 4 equals -1. We'll call it -1 over 1. So we can use the change in y over change in x concept there. -1 for x and 4 for y would make both sides 0. So that's the point where we're going to start. And then we're just going to go down 1 over 1 to create some new points. Okay. Last but not least is actual equation writing. So with the equation writing, this is why it's extremely important to be very familiar with both slope intercept and point slope, because you have to know kind of which form to use, which one's going to be best for that particular situation. And to be perfectly honest, it kind of comes down to this. In both cases, you need slope. In point slope form, you can use any point on your graph, not necessarily the y-intercept. And in intercept form, you need the y-intercept. Okay, so for number 7 here, I'm going to use y equals mx plus b, which is our slope-intercept form. I've been directly told the slope, and I've been directly told the y-intercept, so I simply put them in where they're supposed to go in the equation, and I'm all done. Pretty straightforward. This one I was given a point and a slope directly in number 8. The thing that I have to keep in mind here, I'm going to put my slope in first, is that you have to use the opposites of both of those numbers. So I'm going to use a -5 and a +1. The reason we're using opposites there is really for the same reason we talked about above. Think about how you would come up with -1 and 3 for that first one. Well, you were thinking of what would I plug in to make both things 0, right? So after you create the equation, what you should be able to do at that point is plug the -1 in for x and the 5 for y, and you should get 0 equals 0. Okay, so that's why we have to use opposites there. Now, for both numbers 9 and 10, you're basically given very similar information to what you're given in number 8, but you're given the slope part indirectly. So what you have to do is figure out, how do I use the information that's there to figure out the slope? Okay, so for example, for number 9, I can immediately start with y plus 2 and x minus 3 in parentheses. The only thing I'm missing is the slope. So what I have to look at now is, what have I been given and how can I figure out the slope? What I've been given is 2 points. Okay, so I can look at my slope in terms of the change in y over the change in x, and I can just subtract those numbers or do something else to calculate the change. -2 to 1 is my change in y. That's an increase of 1 in the positive direction. I've also got a change from 3 to 0. That's a change down 3 in the x direction. So my slope would be -1/3. You could subtract those numbers and it would turn out exactly the same. Now, you could also, for this one, this was kind of a little bit tricky, but there's a secondary answer here. You could have also done y equals -1/3, -1/3 x minus 1. You could have used slope-intercept form there. And the reason you could have used slope-intercept form is because even though this point isn't directly labeled as the y-intercept, it totally does work for that purpose. Okay, because it's 0, -1. So if my x value is 0, that is the y-intercept. Okay, so you could have done that too, though I would expect many of you would give me something along those lines. For number 10, again, you are told the point part directly. You are not given the slope directly. That is the problem that we have here. Okay. So what we're going to do is, now we have to figure out how to take this perpendicular line and figure out what is the information we need and what are they trying to tell us. Again, what we're trying to figure out from this information is the slope. okay? And what we know about the slopes of perpendicular lines is that they are opposite reciprocals, meaning I've got to turn -5/1 into a positive number and flip the fraction. So I'm going to turn it into +1/5. And that would be the slope of a line perpendicular to it. So the slope of my line is 1/5. Okay. That was pretty much it for the review. Now, Beatrice asked a good question. Is it possible to do a vertical and horizontal equation problem? I don't remember if I announced in both classes. I'm actually not going to put that on your test, though it is something that I do want you to know, and it is something that will come up later in the year. So really quickly, I am going to do one of those. I do think it's a good idea. I'm going to steal this graph from up here. I'm going to erase some of this stuff up here. Okay, and I'm going to actually, what I'm going to do is this. We're going to do two problems, actually. We're going to do a vertical one, and then we'll do a horizontal one. Okay, we'll do the vertical one in blue. Vertical. So I've got a line that's vertical, and it goes through, we're going to keep it simple, 3, 2. Okay, 99% of the time when you're writing an equation of a line, you need to include an x and a y. And the reasoning is really pretty simple. Take a look at this graph over on the left here. The x and the y values are constantly changing. Constantly. You can't move from one piece of that line, one point on that line to another point on the line without changing both the x and the y value. So because they're both changing, that means our equation has an x and a y, right? Because if I change the x a little bit, that would change the y a little bit, little cause and effect there. With a vertical line, though, this is different. I'm going to plot the point 3, 2. Then I'm going to physically just draw a vertical line, okay? This is what it would look like. What I need you to notice is this. To move here from one point to another, my y values are changing, but my x values are never changing. The important piece of this here is that for all of these points on the line, my x values are 3. That's it. So the equation of my line is x equals 3. Now you can ask yourself, well, why isn't y a part of the equation? And that's because y can literally be anything. The only requirements, what you're doing when you write an equation is you're basically writing what are the requirements for a point to be on this line. The only requirements for a point to be on this line are that the x value is 3, the y value can be whatever it wants. The exact opposite is true if we look at a horizontal line. Okay, if we look at a horizontal line going through 3, 2, just draw that on there right now, the exact opposite is true. Again, an equation gives you the requirements for a point being on that line. And the requirements are just that the y value must always be 2 because my y value is never changing. My x value is a lot of different things, but it can be anything it wants to be on that line. I could tell you something as an x value of 50 and a y value of 2. It's on that line. We don't see it. It's way over on the right somewhere. Okay, but in the end, it's definitely on my line. Okay, so that's in the end, vertical is always going to be written as x equals a number. Okay, and we're going to be pulling the x value from the equation, and horizontal is always going to be y equals a number, and we're pulling the y value directly from that equation. Okay, hopefully that horizontal vertical explanation was helpful. If you're watching this later and you just had a question or something that came up and you're just quite not sure, or there was something I mentioned in here that you're not quite sure of, or you just want to work on some things, come find me tomorrow. I'll be around before school for a little while, and I have to go outside for recess tomorrow, so unfortunately I can't help you for recess. Will there be Beatrice asked, okay. A couple more questions popped in. I'll answer those real quick, and then I'm out of here. Will there be decimals and fractions on the test? Not directly. So, I mean, I've shown you a pretty good set of examples for what'll be on there. I mean, the only thing where fractions will pop up is obviously as slopes. But beyond that, like even in making a table of values, I've given you equations that you shouldn't need to use decimals and fractions, so you should be okay there. And George, the next unit is going to be solving systems of equations. And no, I can no longer throw my cat because remember, I don't have him anymore. Otherwise I would. Okay. Thanks for hanging out at the live stream for a little while, and hopefully it was at least a little bit helpful. And again, if you have questions, just let me know. If not, I'll see you whenever you're taking your test, either tomorrow or Monday. Thanks all.